Welcome to Math TV with Professor V. I am finally back and it is Saturday, July 1st, 2023. Here's your integral of the day. We have a definite integral from the square root of pi over 2 to the square root of pi of theta cubed cosine of theta squared d theta. And I will give you a little hint. First, you're going to need to make a substitution and then use another integration technique. So if you want to pause the video and give it a try, feel free. First off, I'm noticing I have a composition of functions. I have cosine of theta squared. And since we're going to make a substitution first, seems like that's going to be a natural choice for our substitution. I'm just going to let, in this case, t be theta squared. Why t and not u? Because I'm feeling like we're going to have to do by parts next. So before I go ahead and make the substitution, I'm going to rewrite the integral so you can kind of see what's going on. So we have rad pi over 2 to rad pi, and I'm going to think of this theta cubed right here as theta squared times theta, and then we still have that cosine theta squared d theta. So now let's make our change of variables. I'm going to let t be theta squared, then dt would be 2 theta d theta, right? That's good. Because notice here, okay, this theta squared, that's t. And then right here, we have a theta d theta. Ooh, that matches so beautifully right here. So that means 1/2 dt is theta d theta. You got it. And then again, no big deal. Here's my t. So we can make a nice substitution and rewrite everything in terms of t. And then don't forget, you have to switch those limits of integration, rad pi over 2 to rad pi. So t of rad pi over 2, because right now these are limits for theta, right? They match this variable. I got to switch everything to t. So t of rad pi over 2 is just going to be rad pi over 2 squared, so pi over 2. And then t of rad pi is just pi. Oh, look how nice. Whoever picked these limits of integration must have loved us because they wanted it to work out nicely after we did this substitution. Okay, so let's rewrite it now. New limits go from pi over 2 to pi. Watch the color coding. So this is a t. I'll stay with the same t. And then I have cosine of t, yes. So I did all the yellow stuff, t, cosine of t. Then remember, theta d theta, that's 1/2 dt. That's 1/2 dt. Put the 1/2 outside, right? Get those constants out. Bada bing, bada boom. How are we doing? Good. Can you see it's time for by parts? We have a product of two functions, t and cosine of t. So now let's pick u and dv accordingly. That's why I wanted to save u. That's why I did t earlier and not u. Okay. So if I have a trig function, you don't want to let that be u because here we have a polynomial, just t to the first, so that's a good choice for u. So u is going to be t, and then dv will be cosine t dt. Now let's find du. Du will just be 1 dt. And then v, go backwards. Antiderivative of cosine t is sine t. All right, here we go. Just keep that 1/2 outside. And then we're going to have this product here. So t sine t, that does not get integrated, just t sine t. And then remember, we have limits of integration, so we'll evaluate that from pi over 2 to pi in just a second. Minus integral of v du, this product here. So that's sine t dt. Sine t dt, and then here again, don't forget your limits of integration, pi over 2 to pi. That we will anti-differentiate in just a second. And remember, we have that 1/2 outside, so put some, put some nice brackets here, okay? Because this will distribute later. All right, let's evaluate our limits of integration after we finish anti-differentiating everybody. So what do I mean? I'm not going to plug in pi over 2 and pi here. Just leave it right now, t sine t. And then minus antiderivative of sine t. So whose derivative do you take to get sine t? Negative cosine, and then I have another negative. So this is going to be plus cosine of t. And then now everything's going to get evaluated from pi over 2 to pi. See that? Fabulous. So then we have 1/2. Now substituting in pi times sine of pi plus cosine of pi, upper limit minus lower limit, pi over 2, sine pi over 2, minus, yep, I'm distributing the negative, whilst I evaluate. And then now let's see, just think of your unit circle. 1/2 times pi, sine of pi is 0, cosine of pi -1, minus pi over 2, sine of pi over 2 is 1, cosine pi over 2 is 0. And then now let's distribute this 1/2. Okay, this is a 0, this is a 0. So I've got 1/2 times -1, that's -1/2, ba-doo, and then one more right there, that's going to be minus pi over 4. And that's our final answer. How did you like this one? I thought I'd come back with a bang. So thank you for your patience. I was traveling for almost the entire month of June. Now I'm back, and it'll be back to your regularly scheduled content, if not more. So I'll be doing integrals of the day, and then as I've promised for quite some time, I'm gonna add on to the linear algebra differential equations playlists. If you're a member, you have access to those, and then I'll be uploading more practice tests, worksheets, videos to my Patreon for those of you who like a little bit of extra support and resources. And if you have any other video ideas just for Calc 1, 2, 3, pre-calc, things like that you're missing, let me know. I'm happy to take requests from time to time. But as always, if you want exclusive content, particular videos, all of that stuff, then you got to be VIP. So a couple places to do it. The best one is Patreon. All the info is in the description box. You can also catch me on Instagram and TikTok at MathTV with Professor V. I missed you guys. Love you. Hope all is well, and I'll talk to you soon. Bye.